Tonight is a special lecture within our lecture series. It's the Ocean Stewardship Spotlight, and it helps to share the many stories of hope and encouragement and engagement that happen in different communities around different parts of our ocean. But we always like to bring it back to Massachusetts, which is such a great place to show that what's going on all around the world, but some really great projects, which of course is the core of the aquarium's mission as well. Our speakers tonight are great examples of this by telling the Massachusetts version of this story, supporting those that work to protect our oceans and engaging the public. They are, in fact, ocean stewards. We hope you are inspired by their presentation tonight, see the many connections to your own daily life, and look for opportunities to engage with the many different citizens groups that make these projects actually possible. Please welcome Pam and Samantha.
So let me just give you a heads up on what I'll be talking about for the next 25 minutes or so, and then it will be Sam's turn. But I want to talk to you about the fact that just as Massachusetts bays are part of a larger ecosystem, the MassBays National Estuary Program is also part of a larger organization. The diversity encompassed in our region makes planning and comparison across the region pretty difficult to do. And talking about trends and conditions in all of Massachusetts Bay and Cape Cod Bay is a little difficult to tease out, but I'm going to try anyway. And finally, we'll make the pitch for why and how MassBays can do a lot in terms of bringing together and synthesizing information and putting that information to work for the health of our estuaries. So let's start with the big picture. This is a map of all of the national estuary programs. There are 28 around the country. We're in Region 1 of EPA New England, along with 6 national estuary programs in our region. If you zoom in, you'll see that we're part of the Gulf of Maine. And then if you go 10 times closer, you get to the Bay State. And there is our planning area. Massachusetts Bays Program pays attention to estuaries from the border of New Hampshire all the way around to Provincetown. We have a sister National Estuary Program down in Buzzards Bay, down here where Fall River and New Bedford are, and they are also, they're similar to us, get the same kind of funding and everything. And before I gallop on, I should say something about what estuaries are, so that we all are starting from the same place. So an estuary is a place where fresh water from rivers meets the sea. And so that interface where salt water and fresh water meets, where the nutrients that come down from the rivers and the fresher water, I shouldn't call it fresh water, but the less concentrated nutrients of the ocean mix, it's a really good place for animals of all kinds to live. And so there are things like salt marshes in estuaries. There's eelgrass. Eelgrass is a seagrass that lives underwater. It forms a really nice place, nursery for shellfish and finfish, for example. And pretty much all of the commercial fish that we depend on spend some part of their life in eelgrass. So Gina gave some hint of Massachusetts Bays National Estuary Program's vision. We envision a network of healthy and resilient estuaries, and they should be sustainable ecosystems that support the life and communities dependent on them. And the way we do this is by facilitating partnerships to prompt local, state, and federal action and stewardship. And we can do that by convening stakeholders, providing a scientific basis for management decisions, and then bringing problems and solutions to decision makers. To be able to do this on-the-ground work, and because we have such a large region, it has made a lot of sense to work on a sub-regional basis. So we've split the region up just for management purposes into 5 sub-regions. Samantha works with us out of the South Shore region, and she'll talk a little bit more about that. Then, from a scientific basis, to start to wrap our head around what's going on, we've identified or delineated 47 embayments. So an embayment is like it's a estuary in its own right. We've defined them on the landward side as the drainage area, kind of the mini watershed to that particular small estuary. It also counts how far up the tide goes up the rivers. And then offshore, we looked at things like eelgrass and more coastal habitats and calling that the outer boundary of the embayment. If you go onto our website, and this will be my one plug for our website, is www.massbays.org. You can find maps of all of the embayments where you can go in and decide which natural resources, whether it's a fish run or a salt marsh or eelgrass beds or shellfish beds, and layer it with some of the stressors. So for example, if you're looking at a herring run, you might want to know where the dams are or where the road crossings are. And you can look at those two layers together and think about them as one. Then we talk more about the fact that every 5 years, all of the National Estuary Programs put out a State of the Bays report. So most of what I'm going to talk about for the next 15 minutes or so comes from the speakers at our most recent State of the Bays Symposium. It was a one-day event on April 15th, and we had about 25 speakers. And so I'm really condensing what they had to say, and hopefully I haven't made any mistakes. If I do, they're all mine and not the speakers. This is a really nice photograph that was taken from the International Space Station. Canadian astronaut Chris Hadfield tweeted this out while he was up on the space station, and I grabbed it, because that's, of course, our vision of the world, right? This is a simulation of currents and temperature in Massachusetts Bay and Cape Cod Bay. So the darker blue colors is the colder temperatures, and then the reddish ones are more warm. If you look at the little arrows, you can see some of them are really short and some are longer. The length of the arrow indicates the strength of the wind or the current. And then across the top, you can see where we're going in terms of the year. You can also tell, look at Cape Cod Bay, you can see why poor sea turtles sometimes get stuck in there, get stranded and cold shock. Because it stays pretty warm down in Cape Cod Bay, and then the cold water comes down from the main coastal current and really cools it off pretty quickly. So all of this diversity has been documented by the Census of Marine Life, which took place between 2000 and 2010. They were able to go out and figure out all the different species that live in Massachusetts Bay and Cape Cod Bay. I'm a microbiologist, and I always say that there are 100 times more species than this, just if you look at the bacteria. But these are the ones that most people can see without a microscope. Then they also identify the important habitat areas that support all of this diversity of life. All of this diversity is, in turn, generated by the diversity of physical characteristics in the bays. This is a map that was generated by the Massachusetts Office of Coastal Zone Management as part of the Massachusetts Ocean Plan. Massachusetts was the first state in the nation to put together an ocean plan, and it actually served as a model for the national ocean planning. So here again, we can look at some of the diversity. When you look at the north shore around Cape Ann, those dark dots are rocks and rocky bottom. The yellow is more sandy, and then the blue is mud. So you can see, even from North Shore through Boston down to the South Shore, there's a lot of diversity, and that it supports a lot of different types of life, as illustrated in this map, another one from the Massachusetts Ocean Plan. The dark green here is salt marsh. The largest one here up on the North Shore is the Great Marsh. That's the largest contiguous salt marsh north of Long Island, New York. And it's right here in Massachusetts. There's also a lot of eelgrass, as I mentioned earlier. Eelgrass is nurseries of the sea. That's the lighter green. And then if you look, here's the brown in the middle. This is a hard and complex seafloor that the lobsters prefer. And we all depend on these resources. The Massachusetts economy is consistently held up. About 79% of the Massachusetts gross domestic product is coastal industries. And here in 2012, you can see the split. Tourism and recreation is a big one, as well as transportation, the ferries, and the cruise ships that come in. They all depend on the coastal system. That pie is about $300 million during 2012. So that's one example of how we're connected to the coast ourselves. Another example of how what we do is connected is the fact that New England has seen the highest rate of sea level rise and also the highest increase in extreme precipitation. These maps were shared by National Oceanic and Atmospheric Administration and the National Weather Service. And when you talk about extreme precipitation and more frequent storms, these may be familiar pictures to you after this past winter. The storm surges, the waves that come up with these coastal storms, and the flooding that results is becoming a familiar sight, unfortunately, and it's especially familiar on the South Shore. Each of these bars, so South Shore has claimed the most from National Flood Insurance Program. You see that the amount that's being asked for has been pretty large in the past. So the blizzard of 1978 and then into 1991, Hurricane Bob. And so we're asking for less money as it comes closer to present day, but the storms are becoming more frequent. One of the reasons it's a concern is that there are a lot more people moving and building at the shoreline, even in the face of all this. The place that we were just looking at, the South Shore, that has so much flooding and national flood insurance claims, is also one of the fastest growing areas in Massachusetts over the past 8 years. These are data compiled by the Mass Audubon. They put out a report called Losing Ground every few years, and this is they look at the change in development rate over time. They also have tallied up how much of our land is up for grabs. About a quarter of Massachusetts land has been set aside as permanently protected, but there's about half of our land that is still out there, and we're not sure what's going to happen with it. And we prefer not to see it all developed and turned into impervious surface. So impervious surface, if you're not familiar with that one, is buildings, roofs, and parking lots, and in a lot of cases, even people's lawns turn into impervious surfaces because they really don't let a lot of water percolate through. And one of the things that happens because of that is that we end up sending a lot of polluted water out to the bays and the estuaries. One of the indicators of that is the way that our beaches have shown exceedances, so it's gone beyond the limits for safety for bathing at some of our marine beaches, and it's associated with rainfall. So the rain comes down, washes off the streets, and brings the polluted water down to the beaches, where it gets tested according to state law. The Department of Public Health collects all of the data and compiles a report every year. So this was some of the data that they shared. They told us that in 2013, 66% of the exceedances were correlated with rainfall. So that's a significant portion. That if we just paid attention to how we're treating stormwater, we might have something that might have a better chance of being able to go to the beach a couple days after the rain comes down. Another impact of contaminated stormwater is eelgrass. Nitrogen loading, especially from fertilizers, if it ends up in the water, will cause a reduction in eelgrass beds. So again, the eelgrass is really important as nursery area. If you look at, here's Duxbury Bay. Since 1951, that whole eelgrass bed has disappeared. And then here in Kingston Bay is also almost disappeared. We've lost about 2,000 acres of eelgrass since 1951 and 700 acres alone, 36% since 2012. The Massachusetts Division of Marine Fisheries has been spending a lot of time trying to go out and map the remaining eelgrass so we can figure out where it still is and try and help expand those beds. We've also, MassBays has a little bit of money to help researchers, and one of the things we've invested in is to help with a rapid assessment for invasive species that goes out every 3 years. And they've figured out that in the past several years, since 2007, 12 new species have been identified in Massachusetts, MassBays. These are invasive species, or non-native, I should say, non-native species that have been identified. So about, if you were to go out and grab any sample in Massachusetts Bay, about 75% of those species would be native, about 14% would be introduced, and about 9% there's still up for debate whether they've always been here or whether they were introduced later. Another trend that we can look at is shellfish landings and how healthy the shellfish beds are. The top graph on this here looks at the value in dollars of shellfish that's brought in, and then the bottom is how many pounds. The one that's going up so much is oysters, and it's primarily because of aquaculture. You might recognize our friend the piping plover. These little birds nest in pretty exposed area on beaches. And you may, when you go to the beach in the spring, see ropes around their nest to keep people out and keep from trampling them. They've actually had a pretty nice rebound from a loss in abundance in 2013. We'll wait and see what happens this year because we only have 1 year of data with them rebounding. So abundance is the number of pairs, it's the blue bars, this number of pairs that are actually out there. The orange line points at how many babies, how many fledglings each of the pairs has. And so productivity is a measure of how many baby birds are coming out of a given population. One of the surprising things that Mass Audubon shared with us using data from the Massachusetts Natural Heritage and Endangered Species Program is that over the past few years, it looks like abundance has been increasing on the North Shore, around where Revere Beaches, for example, has been a really nice place for the piping plovers, and they're starting to be less common on the Lower Cape. And they think that one of the reasons is that there are fewer predators up on the North Shore than on the wilder beaches down on the Cape. And also there's been a really nicely coordinated effort to help the plovers on Revere Beach, for example. I just want to point out, too, that the Mass Natural Heritage and Endangered Species Program is that little checkoff box on your state income tax. You can give them $1, and this is the kind of good stuff we got out of that. Another piece of the puzzle is looking at river herring and how many fish are making it up our rivers. Samantha's going to talk a lot about how we get these data, but we can look at, there are more lines on the latter half since 2012. MassBays funded a project to combine or start a river herring network of the herring wardens in towns. And so they've been able to pay more attention to and provide more data to the Division of Marine Fisheries for stock assessments on herring. And there's some good, nice, happy news here. For example, on the Stony Brook in Brewster, the Division of Ecological Restoration, another Massachusetts agency, did a large dam removal and stream restoration project in Brewster, and it's been an amazing recovery of the herring just since that project has been done. And actually, I noticed today that Metro Boston, the Charles is going down, which means I have to talk to the dam operator on the Charles, because the way that the herring get upstream on the Charles is that they have to open up the gates on the dam and let the fish through. So, to give you a summary on the data portion of my presentation, is really MassBays, we have a history of supporting generation and dissemination of information on MassBays. And when we first started in the 80s and early 90s, we had a nice pot of money that we were able to hand out to researchers to go out and characterize, especially Boston Harbor, because MassBays was formed with some of the funding that came out of the lawsuit to clean up Boston Harbor. More recently, we've been able to provide small grants for research and planning that supports management decisions across the region, especially with municipalities as they try to figure out how to handle stormwater. And then this summer, we're coordinating the National Coastal Condition Assessment for Massachusetts, which is part of a national effort to go out and look at what the near-shore water quality looks like. One of our goals in doing all of this is to move from this idea of cacophony where everybody's doing their own thing and tooting their own horns, but not necessarily paying attention to who's listening or where it's going. And instead, we want to get to this idea of collaboration, where you don't have to be playing the same instrument or even being in the same key, but at least point it in a direction where people can use it and be able to tell a story with it later. The way we are able to do that is by bringing together a lot of different stakeholders. I like to call MassBays the friendly arm of EPA because we're not a regulator, we don't write regulation, we don't enforce any regulations. We get to be the happy people who come in and say, you know what would happen if you did this cool thing. So we are sponsored by funding from the Office of Wetlands, Oceans, and Watersheds, OWOW, at EPA, and the Executive Office of Energy and Environmental Affairs here in Massachusetts. Our central Boston staff sit at the Office of Coastal Zone Management, and we have a coordinator at Region 1 EPA here in Boston. And we have an amazing group of partners on a management committee who help us figure out path forward. But even more amazingly, we have 5 terrific partners. Actually, we're seeking a 5th partner now to work with local governance committees, people who work in the towns, who are there every day and are able to talk about priorities in their own communities, and then bring it to the regional coordinators who sit in our partner organizations. Here's a list of our management committee members. They come from nonprofits and businesses and the academic community and government. And really, you look at that list of government agencies and they often don't get to be together in the same room because they're also busy trying to meet their own mandates. Our quarterly meetings are one of the only opportunities they have to sit and talk about what they're working on in the bays. So they're very productive meetings, I think, and we've been able to pull a lot out of them. So with that, I'm going to turn it over to Sam, and then we'll do questions after that, right?
Thanks, Pam. Hi, in case you forgot from the introduction, my name is Samantha Woods, and I'm the Executive Director for the North and South Rivers Watershed Association. We're a local nonprofit located on the South Shore, grassroots environmental organization founded in 1970. We have approximately 1,200 members, and our sort of geographic area ranges from Duxbury up to Hingham and as far west as Weymouth. We have 12 communities in our watershed, and we also are the South Shore host for the Bays program, what that means is that some of that flow chart you saw with all those boxes means that some of the money from your federal tax dollars goes up to EPA, and EPA brings it back down to the states, and the states bring it to organizations like mine and yours, nonprofits, small nonprofits like ours that are on the ground doing a lot of really great work. And I'm sure wherever you live, there is a local watershed association like the one that I work for. Our mission is to protect and restore our rivers and the watershed that drains into them and educate the next generation of river stewards. And part of how we do that is engage citizens. That is what our work involves, is really talking to people about the resources that are in their own backyard, because conservation starts in your backyard. So what I'm going to be talking to you about tonight is our role in training and working with citizen scientists. We couldn't do that without the Bays program support, because that funding that comes to us goes directly to a staff person, a staff scientist, Sarah Grady, who I've listed on this slide, because really a lot of the work that I'm going to show you tonight is the result of her efforts. I also want to just give you a plug for our website, which is nsrwa.org. So if you'd like to find out more about who we are and what we do, and if you happen to live on the South Shore or know people that do, please let them know about us. It's a great organization, and we're always looking for new members and people to be engaged. So why would we engage volunteers in monitoring the environment? First of all, why would we monitor the environment at all? Would you ever go to a doctor and expect him to give you a diagnosis if he didn't take your temperature, or draw your blood, or check your pulse, or your blood pressure? These are basic measurements that scientists and doctors use to assess how healthy we are. And, that is exactly the same kind of principles that we use when we're going out and monitoring the environment. The environment, of course, is very complex. We've got multiple stressors, both human and natural, at work, and trying to tease out information out of that is very challenging, which is why we really need a lot of people doing it. So much needed labor is one of the reasons why we engage volunteers in monitoring the environment. As Pam pointed out to you, we have a pretty large coastline to cover, over 1,000 miles of coastline in the Massachusetts Bays area. That's not my coastline in our watershed, but that's the entire Massachusetts Bay. So we really rely upon citizens volunteering and getting engaged with us to be able to have just the manpower and the eyes and hands out there doing this kind of work. At the same time, our state and federal government resources, which really would never be enough. I mean, there's just not enough resources available for this kind of work, even if we were really well funded. But even now, they're much more dwindling, as we have seen in the last decade or so, as our state and federal budgets have decreased. In fact, the state of Massachusetts budget for all the environmental agencies is less than 1%. In fact, right now I think it's hovering around 0.6% of the state's annual budget. And of that, a very, very, very small piece would actually go to do the kind of monitoring that we're talking about. Most of it is towards the regulatory enforcement arm and the permitting and all the other things that go on. So government, I think, really relies upon citizens to collect data for them. Not only is it important, it's also a great way for us to educate people about the environment. It enables us to really dig a little bit deeper and provide a little bit more sophisticated education to people. Nothing beats getting dirty and muddy like the kind of work we do. It really gets people into the environment, and you don't protect what you don't know. So if you live it and breathe it and you start to become intimate with it, now you're going to be a little bit more protective of it. And so people become more vested the more they become engaged in our scientific endeavors. It also enables us to hold government accountable. We have a lot of laws out there on the books, Clean Water Act, Clean Air Act, multiple environmental regulations, Endangered Species Act. And those laws rely upon data. We have to prove to the government if they're not doing their job. So a lot of the data we take actually is used in decision making and sometimes in law, in court cases. We need to measure our own progress. So not only do we need to hold our government accountable, as a nonprofit, we are taking people's money. We are trying to do good things with it. And this is one way that we can measure our progress. So it's really important for a lot of different reasons that we engage volunteers in monitoring our environment. So, in my ode to David Letterman, I have 5, not 10, reasons why volunteers should participate. And this is actually data from a recent study, a survey of river herring count volunteers throughout New England. It was done by Dartmouth, where they went out and they actually surveyed some of our own volunteers who do river herring counts with us. So, number 5, to learn, this is what the volunteers said in the surveys that we took. To learn more about river herring, and I say insert here any animal, plant, or physical measurement, because I think you could translate this into any volunteer citizen monitoring program, not just river herring. So they want to learn more. Yeah. They want to get outside, thank God that people still do, and that we're not all so chained to our iPhones, iPads, Kindles, God knows what other screen time that we've got going on. I'm looking at my son. We want to get outside, and we want our kids to get outside, and we want them to learn. So getting outside is one of the reasons our volunteers participate. In this case, number 3 reason that river herring counters wanted to be involved in our counting programs was to actually improve the management of the river herring. Again, insert any environmental cause there. 2, to help protect nature. And 1 was because they were most concerned with the health of the ecosystem. So for us, now we have identified the perfect member. This allows us to kind of tease out who's the real deal, who's able to get muddy and get outside with us, and who will stick with us doing some, sometimes challenging outdoor work. It's not all fun. And so we can kind of separate the wheat from the chaff here and see who can stick it out with us. And oftentimes the people who volunteer for us become our next generation of leaders in our organization. Our current board president is a river herring fanatic and spends I don't know how many hours counting herring. So that's one way that it's a benefit. So it's a mutually beneficial relationship for the organization, for the environment, for the volunteer themselves. I think actually find themselves in a much better position. They like doing it. I think they feel happy getting involved with us. They feel like they're doing something good for the environment, which I think in this world where we're continually getting a lot of bad information about the environment, giving people an opportunity to do something useful and worthwhile enables us to feel empowered as citizens. And so that's really what we want to do. We want to empower people to realize that it's not just a bunch of bad information on the TV, that there is a way that we can make a difference. And it can be as simple as going out and counting horseshoe crabs having sex. So this is a photo that was taken on Duxbury Beach of 2 crabs going at it, horseshoe crabs. A little crab porn here for you tonight. Taken by a person who's actually in the audience who came upon us. She's an environmental photographer. Her name is Lauren Owens. I want to give her some credit. She took these wonderful photos of our volunteers doing the horseshoe crab monitoring and actually put this into our local regional paper and wrote a wonderful article. So it gets us a lot of good press. So that's good. It's engaging our citizens. So one of our citizen monitoring programs is actually going out and counting horseshoe crabs. In early May and June, horseshoe crabs come into the shallow, calm waters of our estuaries, like Duxbury Bay. This is where this is. And they lay their eggs. They prefer to spawn during spring high tides that occur around the new and full moons, on the day and night of the full and new moons, as well as 2 days prior to And following these dates, our volunteers walk about 650-meter length of the bay shoreline, and they count clusters of crabs. The data is collected to use and used to calculate two metrics. One is density, that is number of crabs in a square meter, and then the spawning index, that's the number of females in a square meter. We've been collecting horseshoe crab spawning data in Duxbury Bay since 2008. And that data has really helped, we provide that data to the state to help them in understanding the effectiveness of some regulations that they have put in place more recently, and to help evaluate the status of horseshoe crabs along the East Coast. We're part of a larger network. Horseshoe crabs, if you're not familiar, are actually harvested for bait for the eel and conch fisheries, as well as their blood is used and processed and used to test products for sterility. So there actually was a decline in the horseshoe crab population in the early 2000s, and there was no population data being taken, no spawning data. What they have was landing, fish landing, how much were they capturing. In 2008, there became more awareness of the need to collect more data. The map on your left shows, not so greatly, but let me point it out to you. These squares and triangles on this map depict horseshoe crab spawning beaches. And what I really just wanted to point out to you is that there's more spawning beaches than there are areas where we're counting. So these little dots here are the 4 areas where we've actually had consistent and relatively long data collection of horseshoe crab spawning since 2008 to now. Sporadically, other beaches do get counts. And this is our beach up here, the Duxbury Bay area. I think Pam was mentioning the diversity. Horseshoe crabs don't spawn on the North Shore for some reason. It's not the right habitat. They need some long sandy shorelines, which we have as they move down south of Boston Harbor. And again, there's plenty of opportunity for you to establish your own horseshoe crab spawning citizen science beach if you'd like. So more areas to cover than we can possibly do. And it's great fun. Our citizens go out with their families. Grandparents down to kids are going out and checking out these horseshoe crabs. They go out in the middle of the night, because that's sometimes when the lunar tide is, and they've got their little headlamps on, and they're walking up and down Duxbury Beach looking for these guys. And it's a wonderful experience for their family, and they're collecting good information for us. So it's a win-win for all of us. Here's another wonderful picture taken at Duxbury Beach just this past, we're right in the midst of the spawning cycle right now. So some of the data, so based on 2012 surveys that were done statewide, 146 volunteers helped assess horseshoe crabs throughout the state at those sites that I was showing you. On our own Duxbury Beach from 2008 to 2014, 44 volunteers collected data on almost 5,000 horseshoe crabs over the course of 95 surveys. And the data showed us that the spawning population last year was down a little bit from 2013 and 2012, but up from 2011 and prior. Compared to other surveyed sites in the state, Duxbury has some of the highest surveyed densities. So it gives us information, it provides information to the state regulatory agencies so that they can monitor how well new regulations that they're putting in may or may not be working. So there has, since the time that the horseshoe crab population has been diminishing, there have been consecutive years of increasingly more strict regulations being placed on the harvest of these species. And so without the data that we're providing, the state couldn't really understand how those regulations might be working. So another type of citizen monitoring that we do is on water quality. We all deserve clean water, but how do we know if it's clean? We want our estuaries to be clean enough to swim in and eat from, and this is a group that I take out people to do shellfishing along our estuary to highlight the water quality improvements that we've made. This is a very happy clamors that I just had out a couple weeks ago. And the North and South Rivers Watershed Association has been sampling water quality at 10 sites along our rivers for 21 years. So we have a really long time frame that we can look at in terms of water quality. and consistency, doing it at the same sites with the same methodology. But it's an all volunteer-driven program. We recruit people every year, we train them, and they go out and do the sampling for us. And this is just a picture of some of those people being trained right here. You can see all age groups. We are non-discriminatory about the age. We like having families get involved. It's really quite heartening, actually, to see people bringing their children out to discover these things. And this is a picture of actually Sarah, who's the scientist in our office through the MassBays program. She swam our river as a fundraiser to raise awareness about how much we've improved the water quality in our rivers. This is just a sample of a year's worth of data, and I want to just point out, sort of in keeping with what Pam was saying, when we have rain events, we see a decrease in our water quality and an increase in bacterial counts. And this was 2014, the summer of 2014. Looked like we had a 3-inch rainstorm just prior to the sampling event in July that we took, and you can see the fecal coliform cones, that's bacteria, exceeding our swimming and shellfishing standards. But what we have found, since we have 21 years worth of data, is that we have been making progress. Since our program started, we've seen improvements in our water quality. In the early years of our program, about 13% of our dry weather samples exceeded the state swimming standards, but over the last 5 years, only 4% have exceeded dry weather samples. Similarly, with the wet weather samples, we've seen at the beginning of the program, 12% of our samples exceeded the state standards, and now we're decreased that to 5% exceedance. So over the years, these bacteria counts, this data that we've taken, we've been able to monitor our own progress and our own advocacy for things like Title V improvements in septic systems, sewerage of certain areas that we knew that the wastewater was not being treated properly, and improvements in stormwater. So it enables us to, as I mentioned earlier, check our own progress and inform the state. The state would not ever be able to take all that data. In fact, I just got an email today from the state's Department of Environmental Protection asking me for our data. So they use that data to report actually to EPA on whether or not they are meeting the Clean Water Act standards. So another program that we run with citizens is herring counts. Yes, we actually have people go out and count fish. We've been doing monitoring herring in our rivers since 2003, but really only since 2012 have we had enough volunteers to make good population estimates. You need a lot of eyes on the water to do this kind of thing, to have statistical significance, to be able to generate any kind of meaningful data. If you're not familiar, the river herring population has been quite decimated. It's decreased by about 90% since the early 90s, and we are really at a critical stage for this species. In fact, so much so that the Environmental Defense Fund and other more legal nonprofits have tried, not successfully yet, but have tried to get this species listed as endangered. If you're not familiar with this species, it's a species like salmon. It comes from the ocean and goes up into the freshwater to spawn, and is very critical to our coastal ecosystems. Heron and other birds, wildlife eat this fish, as well as striped bass and tuna and all the things that we like to eat. So they're what we call a keystone species. A lot of things like to eat it, and so without them, we're we don't want to see this species go away. So just an example of some data from our last year's count. This year's count just finished. We count from April 1st through May 31st in most of our streams. We count at 4 different sites in our watershed. Again, we're part of a larger network of herring counting going on. Herring were seen at all 4 of our sites. From just 5 that we counted in the first herring brook, sort of a misnomer. The first herring brook doesn't have any herring in it anymore. It's in Situate. It's actually a brook that we're trying to bring back that population in. To our best run, which is the herring brook in Pembroke, where we counted 2,853 fish. We had over 109 volunteers counting at these 4 sites for those 2 months. Our volunteers contributed over 237 hours in 10-minute increments. They just have to go and look for 10 minutes at the stream. The only site where we actually have enough data, what we don't have is enough fish to calculate population because the numbers are quite low. But the best run is the herring, Brook and Pembroke, and in that one, in 2014, we were able to estimate about 40,000 fish as the total population that would be spawning in the brook. But that was down from 2013 and 12, where we had more like 100,000 and 80,000. So it gives us some information. It doesn't answer all sorts of questions for us. We think that this last 2014 year may have been an echo of a problem that was in that fish ladder 4 years ago. So river herring mature at 3 to 4 years out at sea, 3, 4, 5 years old. They come back as a mature adult to spawn. They come back to usually close to their natal spawning habitat, that is the place where they were born. And so we think that the last year's population diminishment, the lowering of that was a result of the fact that the fish ladder was broken 3 to 4 years ago in this site. We actually were moving them with buckets. We had a little bucket brigade going on, and so maybe what we're seeing is an echo of that problem with the habitat. So because it's the IMAX, we have to have movies. One of our volunteers has a GoPro, and he put it into the stream, that same fish ladder that you just saw people counting at, and was able to get the fish on video. So I just thought it would be interesting for you to see the fish coming up through the fish ladder and into this pond to spawn. Another type of citizen monitoring we engage in is stream flow monitoring. So we want to know how much water is flowing in our streams. We have stations throughout our watershed. We measure stream flow year-round in a couple of different streams, in part because we're concerned about water withdrawals, and in part because we're concerned about pavement in the watershed. Two things that will affect stream flow: taking water out through pumping, as well as paving over the surfaces of our watershed so that the water can't percolate in and recharge the aquifer. During the summertime, the stream flow is largely groundwater driven in our area. So if we don't have good recharge back into our aquifer, that means that all the water is just draining off the land, off the pavement, and going out into Massachusetts Bay. Then in August, we don't have it to provide stream flow to our streams. And obviously, if you're a fish, you need water, and if you're an aquatic organism, you need water. And so water is important to us. So this stream flow monitoring engaging program is supported through another state agency that we work with often, Division of Ecological Restoration. And here you can just see us taking some high school students out and teaching them how to measure stream flow. They actually were doing a cross-section where they were measuring stream flow in the stream. And then here we place a gauge in the stream, and we have citizens monitor the height of the water every day as much as possible. We get that data, and then we can relate that through a co-relationship, mathematical relationship to the stream flow. And this is just an example of some of that data that we take. So I just wanted to point out to you this because it's sort of interesting. This is a brook that we know is being dewatered by water withdrawals in Norwell and Hanover. It's called the Third Herring Brook. We're actually working to restore this brook. And the sort of purple dots you can see are just slightly above the red diamonds. The red diamonds are actually stream flow measurements at the lowest part of the stream as it enters into the bay, into the estuary, and the purple ones are at the highest part of the watershed, the headwaters of that stream. So in a healthy watershed, you would see perhaps lower flows at the headwaters than you would at the base of the stream, because the watershed that drains to it is draining more water as you get downstream. But in this case, because in between these two gauging stations we have water withdrawals going on, we don't see as much of a differentiation. So we're actually seeing the effects of that dewatering going on. And so that helps us to be able to have discussions with our towns about how they use water. We particularly see a problem in the summertime with, particularly where we live, it's in suburban areas with a lot of grass, a lot of irrigation going on. And it really is a problem for our rivers. We see a doubling of water demand in the summertime, in large part. And these are not coastal, some of our communities have coastal population increases because of the beaches. These particular towns do not. They're just more irrigation going on. So we really have to try to educate people about that. Not only do we monitor the environment, we try to engage citizens in actively trying to improve the environment. And some of the programs that we get our citizens to help us with include the removal of invasive species like this Japanese knotweed that was growing up along our South River in one of the parks that we advocated for. So that's an ongoing program that we've been working on. And we also have some purple loosestrife actually in a site that is a restoration site on that same Third Herring Brook where I was just showing you the stream flow data. We actually are removing dams to restore the herring back to the Third Herring Brook. There's still a herring population, but we would like to increase that population, and we'd like to remove some of the dams that are on the brook that are no longer needed. We had our first dam removal project last fall. It's the first dam removal project in our watershed. That site has been dammed for probably 300 or 400 years. And that is very typical of our coastal streams in New England. We have about 3,000 dams in the state of Massachusetts. And only about 200 of them serve any purpose anymore. They were sort of leftovers from our industrial past. So it's a great opportunity for us to restore habitat by removing dams that are no longer needed and in many cases failing. So some take-home messages about the role of citizen scientists. So first of all, how can you out there in the audience engage? I suspect that you're already somewhat engaged if you're here at this lecture. As Gina had pointed out, the New England Aquarium itself has programming that you could get involved with if you'd like to. But no matter where you live in Massachusetts, I can guarantee you that there is a group that desperately wants your help. So if you're interested, there is a group out there. On the North Shore, I would recommend the Salem Sound Coast Watch, Ipswich River Watershed Association. In Boston Harbor, there's a plethora of them. There's the Charles River, there's the Mystic, there's the Neponset River, all great organizations, Save the Bay, Save the Harbor. On the South Shore, of course, the North and South Rivers, but also the Jones River Watershed. And on the Cape, there's the Association to Preserve Cape Cod, and I'm not sure if the Center for Coastal Studies does as much of this kind of work. But believe me, there is a group that wants your help. And it's fun, and it's engaging. And it's something you can do that's different than probably what you might do for a living. So as Pam mentioned, one of the sort of interesting issues that we face is how do we coalesce these disparate monitoring programs to form a more comprehensive and accurate assessment of the health of our estuaries. It's a challenge. It's kind of like asking doctors to provide information about each of you and then making suppositions about the entire population. So, but we know that with big data, we can do these things. And so I think that there's great promise in taking these data and using them to expand our networks and expand our knowledge so that we can better manage the environment. And we're going to need to manage it. Whether we like it or not, we're already managing it. Sometimes poorly, mostly. The future, I think, of volunteer monitoring is really harnessing our smartphones to capture environmental data. And actually, I just saw the neatest little program where people were taking river herring count video, like the video I was showing you. They were using that video, they had placed a camera in the stream for the river herring when they go by. They put all that video, now that gives you thousands of hours of video, like who has time to look at that? Well, they put it on their website and they're crowdsourcing, having people look at it in 5 and 10 minute increments and counting and then providing the data to the scientists. How cool is that? I think that's pretty cool. So, of course, I said to Sarah at our office, how can we do that? She looked at me like I had another head, probably. So, last but not least, volunteers are definitely not free to us. It takes support like we get from the EPA to have a scientist in our office to be able to go out and manage the people that come to us. As I mentioned, we had over 100 people volunteering for us. That's a lot of cats to manage. and a lot of people to engage with. It's great, believe me. It is so worth it. They, as I mentioned, are the lifeblood, but they're not free. But they definitely are an important aspect of what we do, and we need more of them. So, with that, I think we'll take some questions.
Right,
Sure.
so Cape Cod has, Barnstable County has been directed to do Section 208 of the Clean Water Act, the 208 planning. And so there are a lot of people, pretty much everybody is on septic systems on the Cape, and all the discharges are going into this one aquifer that everyone relies on for drinking water. And as you said, a lot of those discharges, septic systems can't deal with nitrogen. It's ending up out into the bays. So the EPA has told Cape Cod that they need to do something about it. So there's a huge, if you go to the Cape Cod Commission's website, they have a huge matrix of all the different options for things that can be done. Everything from neighborhood treatment plants that are treated to the umpteenth level before being discharged into the ground, to new alternative septic systems for individuals. So there are a lot of resources now for the Cape.
I think that the short answer is that there's probably not going to be a silver bullet for the Cape, and I would imagine there's going to be, and I hope there would be, a lot of resistance to any centralized wastewater systems. So it'll probably be a decentralized approach. Different areas will maybe have different approaches based on finances. I know that there has been some discussion about using shellfish as sort of like an after the effect, sort of, hey, let's put some oysters out in the bay and then they'll suck up all the nitrogen. But I think that has a lot of failure written on it, personally. I mean, you don't want to use something that could go up and down naturally as a population as your wastewater treatment. I think you need to treat it at the source more than you do at the end point. I think it's creative, and I think it could be part of a solution, but I don't think it is the solution. Okay, well, Pam's group can't talk to them because she works for the state, but my group certainly is. But of course, we have a limited reach, but groups like mine certainly are in communication with our legislators often. And we have good relationships with both the federal, state, and local politicians. Some more than others listen to us, of course, but we definitely try to get in their offices and talk to their staff and provide them with education. And I think they rely upon us to provide them some of that. But they are countered by other people. So. Yeah. So the beetle's name is Gallericilla, and it's native to where the purple loosestrife are from, Europe. And it has been tried and true and tested by many scientists and the U.S. Fish and Wildlife Service. So we're not actually introducing something that hasn't been thoroughly vetted, and we're not going to cause any further problems. So it only eats this particular thing. So over here, yes? Well, we train them, so hopefully they have some idea of what they're doing. We do go through training with our volunteers, and we have some checks and balances on that. So when we have really good volunteers, we create sort of a hierarchy where we have them overseeing each other, and we never send usually people out alone, just for liability reasons. We don't want anybody to get hurt, but that can be part of it. I mean, there are challenges when you're working with the public to collect scientific data. Hopefully by amassing big quantities of data, you can kind of get rid of some of those error bars. But, you know, I was just talking to a volunteer who came in today. They were doing the Horseshoe Crabs surveys in Duxbury Bay. Somebody brought their kindergartner, you know, the kids running around, taking the horseshoe crabs and running and putting them in the water. You know, fun like kids do, but we're like trying to count them. So it's those kinds of balances that we have to face. You know, we really want people to be involved, and if they have to bring their kid with them to be able to be involved, well, maybe we'll, you know, have to accept the error that goes with that.
Kindergarten error.
Kindergarten error. Exactly. Does anybody else have any questions, comments? Well, thank you very much. You've been a very good audience.